Okay, in this example, we're applying the central limit theorem. In particular, we're going to find the probability that a sample has a mean which is between two specified values using the central limit theorem. Okay, here's the problem. Suppose scores on an exam are distributed with mean of 920 and standard deviation of 24. If 36 scores are randomly selected, find the probability that the mean of the scores is between 913 and 925. And I want to remind you again, when you're doing the central limit theorem, you need to remember the mean of the means is equal to the original mean. The standard deviation of the means is the original standard deviation divided by square root of n. Okay, so we need to find the z-score corresponding to 913 and also the z-score corresponding to 925. So let's calculate that. Two separate z-scores. A z-score for 913 and then a z-score for 925. Two separate z-scores. So it's going to be 913 minus 920 over 24 divided by square root of 36. Okay, when you go through this calculation, the numerator is going to be -7 over, 24 over 6. Square root of 36 is 6, and then 24 over 6 is going to be 4, which is going to be -1.75. So the z-score corresponding to 913 is -1.75. Now we have to find the z-score corresponding to 925, because the problem was to find the probability that the mean was between these two z-scores. So we need to, between these two scores. So we need to convert each of them to z-scores. Okay, so it's, for the next one, it's going to be 925 minus 920. Okay, so when you calculate this, it's going to be 5 over 4 over, 24 over square root of 36 is 24 over 6, which is going to be 4, which is 1.25. Okay, so we converted them both to z-scores, but we're still not done. Since the problem was to find the area between these two, we need to use normal CDF. And it's going to be normal CDF, the smaller z-score, comma, the big z-score. So normal CDF, smaller z-score, -1.75, comma, 1.25. And when you calculate that, you're going to get 0.8543. And I want to remind you, we do have calculator videos that show you how to use normal CDF. So the answer to the problem is going to be 0.8543, and that is the final answer.